Hello friends, welcome to True Abundant Academy. In the last lecture, we have discussed up to question number 8. So we will discuss question number 9 onwards in this particular lecture. So let's start our discussion. So what is given in the question is that if a point moves along a circle with a constant speed, so let us draw a circle. Okay, prove that its angular velocity about any point of the circle is half of that about the center. Okay, so let us take any point. Let us take any point O on the circle. Okay, let O be a point. Let O be a point on circle. Okay, so let us take O as a pole. Let us take this as point A and this point as B. Okay, let O be a point on the circle. Uh, taking O as pole and the diameter through O as initial line. Okay, so let us take this line as an initial line. Let P be any point at time T. Okay, such that such that let us take any point P. Okay, so let us join this such that POB is equal to theta, such that angle POB is equal to theta. So if this angle is theta and this is radius, so this is also a radius, so this angle will also be theta. So this angle is theta, so angle PAB will be 2 theta. Such that itna, then angle PBA is equal to 2 theta. Okay, by the properties of circle. So the angular velocity of point P about O will be d theta upon dt. Clear है? Similarly, angular velocity of point P about P is equal to d upon dt of 2 theta, because this angle is 2 theta. Okay, so let us consider this as omega. Okay, so this will be equal to this is equal to d of dt 2 times of, let us take 2 outside, so d of dt of 2 d theta upon dt. So this is equal to 2 times of omega. Okay, so let us consider this as omega dash. Okay, so omega dash is equal to 2 omega. This means angular velocity of any point angular velocity of any point about any point on circle is twice the angular velocity about center. Okay, so if we take the angular velocity of this point P about any other point is half of the angular velocity taken with respect to the center. Okay, as simple as that, because we have received that W dash is equal to 2 omega. Here d theta upon dt is omega. Okay, and the angular velocity of point P about B is d of dt of 2 theta. So let us take 2 outside, so 2 times of d theta upon dt. So d theta upon dt is W. So therefore W dash is equal to 2 omega. Okay, let us discuss question number 10. How we can solve this? The body rotates with a uniform angular acceleration if omega is the angular velocity when the body has turned to an angle of theta from rest. Okay, so at theta is equal to 0. Okay, theta is equal to 0, we have W is equal to 0, that is d theta upon dt is equal to 0. So we have the uniform angular acceleration. Okay, so we have d2 theta upon dt square is equal to angular acceleration. So let us, angular acceleration is given by alpha is equal to क्या होता है? Differentiation of angular velocity upon with respect to t. So this is equal to d upon dt of, and w क्या होता है? d theta upon dt. d upon dt of d theta upon dt. This is equal to d2 theta upon dt square. Okay, so let us multiply with 2 times of d theta upon dt both sides. Okay, so 2 d theta upon dt into d2 theta upon dt square is equal to alpha into 2 d theta upon dt. This we can write as d of dt of d theta upon dt का whole square is equal to 2 alpha into d theta upon dt. Okay, so the dt gets cancelled. So let us integrate both sides with respect to t. So this is equal to d theta upon dt whole square is equal to 2 alpha into theta plus constant of integration. So at theta is equal to 0, we have the particle is at rest. Okay, so at theta is equal to 0, the particle is along the initial line. So d theta upon dt is equal to 0 because angular velocity is 0. So d theta upon dt is equal to 0. This implies 0 is equal to, this will also be 0 plus c. This means c is equal to 0. So this means we have this equation becomes d theta upon dt का whole square is equal to 2 alpha into theta. So this is equal to omega square. This is omega. Omega is equal to d theta upon dt. Is equal to 2 alpha into theta. This is the required expression that we have to show. Let us discuss question number 11. If the line joining 2 points, okay, so let us take 2 points A and B, okay, is a constant length A. So the length of AB is A, which is constant. This is constant. Okay, velocities of A and B are in the directions which make alpha and beta with respectively with A. So let us take this as alpha. So this is prove that the angular velocity of AB is given by this. U is the velocity of A. So U is the velocity of A. Let us consider the velocity of B as V. Okay, uh, which makes an angle alpha and beta. So this is alpha and this is beta. Okay, so what we are having is that we have 2 points and the velocity of A and B is U and V, and both are inclined at an angle of alpha and beta respectively. Okay, so let us take the velocity of, in the question, the velocity of A is given as U, and let us assume that the velocity of B is V. So let the velocity of B is V. Okay, which is at an angle of beta with horizontal. Okay, so what is given in the question? AB is constant. So since AB is constant, so the velocity velocity of A relative to B in the direction of AB is 0. Okay, so let us resolve the velocity U and V along AB. So U cos alpha. So the relative velocity क्या होगा? U cos alpha minus V cos beta is equal to 0. तो relative velocity 0 होगा. इसका मतलब V is equal to U cos alpha upon cos of beta. Okay, so let us take this as equation 1. Okay, prove that the angular velocity of AB. Okay, so the angular velocity of AB will be, how we find the angular velocity? Angular velocity. So the velocity along perpendicular, we take the velocity perpendicular to radius vector upon length. Okay, suppose we want to find the angular velocity. What do we do? So suppose this is the radius vector. So we take the velocity perpendicular to this radius vector. So the relative angular velocity of AB is equal to velocity of A relative to B. Okay, perpendicular to AB relative to B along the direction that is perpendicular to AB. Velocity of A relative to B along perpendicular direction of AB upon AB. Okay, so this is equal to, AB is A. So in the perpendicular direction velocity we are having u sin, in perpendicular direction the velocity is u sin alpha, and here it is v sin beta. So the relative velocity is u sin alpha minus v sin beta upon AB. AB is A. So let us place the value of v here. Okay. So this is equal to u sin alpha minus u cos alpha upon cos beta into sin beta upon cos beta into A. Okay. So the angular velocity angular angular velocity of AB. Okay, so we have angular velocity of AB is equal to, let us cross multiply this, to u sin alpha cos beta minus u cos alpha sin beta upon A cos beta. Okay, sorry, this is A now, this is A cos beta. So this is u of, this whole is, sorry, let us take u outside. Okay, so this whole expression is u sin of alpha minus beta upon A cos beta. Okay, this is angular velocity of AB. Okay, let us discuss question number 11b. How we can solve this? The 2 points are moving with a uniform velocity. So let us draw the axis first. So we are having 2 points. So 2 points here. Let us take this as 2. This is A and this is B. So this is our x-axis and this is our y-axis. Sorry, this is B and this is our y-axis. This is our y-axis. Okay, the 2 points are moving with uniform velocity u and v in the perpendicular lines ox and oy. Okay, so this is ox and this is oy. The motion being towards O. So motion is towards O, so the velocity is along this particular direction. Okay, because it is towards O. If initially the distance from the origin are A and B, so initially the distance is A and this is B. Okay, calculate the angular velocity of line joining them at the end of t second. Okay, so let us consider the position of point A is A dash after time t and position of B is B dash after time t. Okay, so see, this is A. So after a time t, since the velocity is u and v respectively along x and y direction, so this is v. So this distance after passage of time is ut, and this distance bb dash after a time t will be vt. Okay, so this distance is b minus vt, and this distance is a minus vt. Okay, so let us join these 2 points. Okay, so let us take, what we have to find is that angular velocity of line joining them. So let us take this as angle as theta. So this angle will be pi minus theta. Okay, so in triangle we are having, so this is our O, this is our A dash, this is our B dash. Okay, so this distance is U minus A minus UT, and this distance is B minus BT. Okay, and this angle is pi minus theta. So in triangle O B dash A dash, we have tan of pi minus theta is equal to OB dash upon OA dash. This is equal to B minus VT upon A minus UT. So this is minus tan theta upon B minus VT. B minus Vt upon A minus U. So we have tan theta is equal to Vt minus B upon A minus U. Okay, so we have theta is equal to tan inverse of Vt minus B upon A minus Ut. Okay, so now let us find the angular velocity. So the angular velocity is equal to d theta upon dt. So angular velocity is equal to 1 upon 1 plus Vt minus B upon A minus Ut का whole square into this का differentiation. So this is A minus Ut whole square into A minus Ut into differentiation of Vt minus B. So this is V minus Vt minus B into differentiation of this is minus U. Okay, so this is equal to omega is equal to this is AV and this is UVT. On here it is plus UVT. So this gets cancelled. So this is AV minus minus BU. This is AV and here we have minus plus B or minus B. AV minus BU upon A minus UT whole square plus VT minus B whole square. Okay, so this is the angular velocity of the line joining 2 points at the end of t second. Okay, so we have this as, let us erase this. Okay, so we have the angular velocity as AV minus BU upon A minus UT whole square plus VT minus B whole square. ठीक है, and so that is greatest when t is equal to this one. Okay, okay, so this is angular velocity angular velocity. Okay, so it is greatest when, अब देखो, this is greatest when the denominator portion is least, when A minus ut whole square plus vt minus b whole square is least. Okay, so let L is equal to A minus ut whole square plus vt minus b whole square. Okay, is least when dl upon dt is equal to 0. So let us calculate dl upon dt. So dl upon dt is 2a minus ut into minus u plus 2 vt minus v into v. Okay, so this is equal to minus 2 au plus 2 u square into t plus 2 v square t minus 2 bv. Okay, so this is equal to 0 dl upon dt. Okay, okay, so this is 0. So this means 2a plus 2b into, sorry, let us further simplify this. So we have 0 is equal to minus 2 au plus bv plus 2 u square plus v square into t. Okay, so this gets cancelled. This means t is equal to au plus bv upon u square plus v square. Okay, is greatest when itna is least. Okay, so L is least or maximum. So least or greatest. Okay, so dl upon dt is 0. This means L can be least or L can be greatest. Or in other way, L can be maximum or L can be minimum. So if d2L upon dt square is less than 0, then L is maximum, and d2L upon dt square is greater than 0, then L is minimum. Okay, so let us find d2L upon dt square. So we have dl upon dt as this expression. Okay, so let us find d2L upon dt square. d2L upon dt square is equal to 2a, sorry, so d2L upon dt square. Let us further differentiate that. This is 2 times of a ka differentiation 0. So this is minus u into minus u plus 2 into v. Vt का differentiation v and b का 0 into v. So this is equal to 2u square plus 2v square. So this is greater than, so d2L upon dt square is greater than 0. This means L is minimum value. This means L is minimum. So L is minimum. Matlab this value is minimum. Okay, so this value is minimum. This means W is greatest. Okay. So let us try to write down the conclusion. So W is greatest when t is equal to this value. T is equal to AU plus BV upon U square plus V square. As dl upon dt is equal to 0 and d2L upon dt square is less than 0. Sorry, greater than 0. Is greater than 0. Okay, so this means L is minimum value. N is minimum value. So L is in the denominator. So since this is minimum value, so the angular velocity will be maximum. So angular velocity is greatest when t is equal to AV plus BV upon U square plus V square. Okay. So we will discuss further questions in next particular lecture. Thank you.